we are going to be looking at direct variation and inverse variation. So first we'll start with direct variation. Now, saying that y varies directly as x, y is directly proportional to x, or y is proportional to x, just means the same thing. So if y varies directly as x, what we would write is y is proportional to x. And that would imply that y is equal to k times x, where k is your constant of proportionality. So if y is directly proportional to x, and we draw a graph of y versus x, the graph would be a straight line. So a straight line graph would represent direct proportion. So this here would be a direct proportion graph. And this direct proportion graph assumes that k is positive. That's why we have a positive gradient. So in this question we have if y is equal to 5 when x is equal to 3, and y varies directly as x, we want to find y when x is equal to 9, and then we want to find x when y is equal to 10. So the first thing we'll do is find the constant of proportionality. So the first thing I'll write is y is directly proportional to x. Then I'll write y is equal to k times x. And I'll use the information when we know the values of both y and x to find k. So we know that y is 5 when x is 3. So I'll substitute this information into this equation here. So we have y, I'll put 5, and that's equal to k times x, and x is 3. And now I'll transpose for k. So seeing that we have k multiplied by 3, I'll move this 3 across the equal sign, and the operation will change from multiplication to division. So I'll have 5 divided by 3 is equal to k. Now that I know what k is equal to, I can work out part A. So part A, we have find y when x is equal to 9. So in part A, I'll write over this equation here, y is equal to k times x. And we know that k is equal to 5 over 3. So we have y is equal to 5 over 3 times x. And now we'll use this information here. When x is equal to 9, we'll be able to find what is y. So when x is equal to 9, we'll have y is equal to 5 over 3 times x, and x is 9. Now remember, this 9 is the same as 9 over 1. So this is 5 over 3 multiplied by 9 over 1. So we'll have y is equal to 5 over 3 multiplied by 9 over 1. So we know you can say 3 into 3, 1, and 3 into 9 is 3. So we do that. So now we multiply this 5 by 3 and get 15, and 1 times 1 is 1. So y is equal to 15 over 1, which is thus equal to 15. So this is your answer for part A. When x equals to 9, y is equal to 15. For part B, we'll be using this information. When y is equal to 10, we want to find x. So we write over this equation here, y is equal to k times x. So we have y is equal to k times x. So we have y is equal to, and k is 5 over 3, so we have 5 over 3 times x. And now we'll use this information when y is equal to 10. So when y is equal to 10, we'll be substituting this y is equal to 10 into this equation here. So we'll have 10 is equal to 5 over 3 times x. So we replace the y with 10, and that's equal to 5 over 3 times x. Now this equation can be written as 10 over 1 is equal to 5x over 3. So now we cross multiply, and we get 1 times 5x, and we'll get 5x. Then we have 10 times 3, and that will give us 30. So now we have 5x is equal to 30. So we'll transfer this 5 across the equal sign, And this is 5 multiplied by x. So when we transfer it across, the operation will change from multiplication to division. So I'll get x is equal to 30 divided by 5. So x is equal to 6. And that's because 5 can go into 30 6 times. Now here I made a little table to represent all the information. So the first thing we know that is, we have y is equal to 5 when x is equal to 3. So we have when x is 3, y is 5. Then we know when x is equal to 9, y is 15. So when x is 9, y is 15. And in part B here, we know that when x is 6, we have y is 10. So when x is 6, we have y is 10. So now we look at inverse variation. So a statement y varies inversely as x, or y is inversely proportional to x, means the same thing. So to write the statement y varies inversely as x, we would write y is proportional to 1 over x. So that would imply that y is equal to k times 1 over x, where k is the constant of proportionality. Now we can simplify this further, because this would mean k over 1 multiplied by 1 over x. So this will imply that y is equal to k over 1 multiplied by 1 over x. So multiplying across, we'll have k times 1 is k and 1 times x is x. So we'll have y is equal to k over x. So when we have y is inversely proportional to x, and we plot a graph of y against x, your graph will look like this. It will no longer be a straight line, it will be a curve. And this graph assumes that k is positive. In this question, we have if y is equal to 5 when x is equal to 3, and y is inversely proportional to x. Find y when x is equal to 9, and also find x when y is equal to 10. So the first thing we addressed is that y is inversely proportional to x. So we write y is proportional to 1 over x. Then this would imply that y is equal to k times 1 over x, which would imply that y is equal to k over x. So now we'll use the information when we know what is both y and x to find k. So when y is equal to 5, we know that x is equal to 3. So we write our equation y is equal to k over x. And now we'll make our substitution for y and x. So we have y is 5, and that'll be equal to k over x, and x is 3. So this means 5 over 1 is equal to k over 3. So we'll cross multiply, and we multiply 1 times k, and we'll get k. And then we'll multiply 5 by 3, and we'll get 15. So now we know that k is equal to 15. So now let's look at part A. We want to find y when x is equal to 9. So we'll write this equation first, that y is equal to k divided by x. And we know that k is 15. So we'll have y is equal to 15 divided by x. And now we'll use this information that x is equal to 9 to find y. So we have when x is equal to 9, we'll have y is equal to 15 over x, and x is 9. Now we can break this down and say 3 into 15 is 5, and 3 into 9 is 3. So we get y is equal to 5 over 3. So we have when x is equal to 9, y is equal to 5 over 3. Now for part B, we want to find x when y is equal to 10. So I'll write back this equation. We have y is equal to k divided by x. And we know that k is equal to 15, so we have 15 divided by x. Now I'll write when y is equal to 10. And I'll substitute this 10 where y is in this equation. So I'll have 10 is equal to 15 divided by x. So I'll put this 10 over 1. And I'll cross multiply. So I have 1 times 15. And that will give 15. And then I'll have 10 times x. And that'll be equal to 10x. Now I have 10 multiplied by x, so I'll transfer this 10 across the equal sign. And the operation will change from multiplication to division. So I'll have 15 divided by 10 is equal to x. And of course, this can be broken down. So we say 5 into 10 is 2, and 5 into 15 is 3. So we'll have x is equal to 3 over 2. So I'll have when x is equal to 3 over 2, y is equal to 10. So I made a little table here to write the information. So first we'll have y is equal to 5 when x is equal to 3. So we have x is equal to 3 when y is 5. Then we have x is equal to 9 when y is equal to 5 over 3. So we have x is equal to 9 when y is 5 over 3. And then we have x is equal to 3 over 2 when y is equal to 10.